Welcome to the Math 9 midterm video review key, and basically in this video I'm pretty much going to solve all the questions from the Math 9 review package. Alright, so let's start off with question number 1 here. Evaluate the following, and that just means find the answer. So question number 1, I have -2 all in brackets to the power of 4. So this 4 right here just means that you need to expand the -2 4 times, all in brackets. That's 1, that's 2, that's 3, and that's 4. Okay. So one thing that you might notice is that we have 4 negative signs. So if you have 4 negative signs, that's an even number of negative signs. So your final answer should be positive. And then 2 times 2 times 2 times 2 will be positive 16. So 16 is your final answer. All right, for question number 1b, I'm going to highlight that 2 to the power 4 because 2 to the power 4 is going to be 16. Very similar to that. And then this negative sign on the outside, this thing just tags along, so the final answer will be -16. For question 1c, I have 2 to the power 4. So this part right here in red, that's going to be 16. And then you have this negative sign that's kind of hanging around, so the negative sign just kind of hangs there at the very end, so your final answer will be -16 for that one. Okay, moving on to question number D. For question number D, you want to do some BEDMAS first, so brackets and exponents. So here's a bracket right now. So 12 plus 12 is 24 times 8 squared. So 8 squared is just 8 times 8, which is 64, times 20 divided by 4. Okay, so once you finish the brackets and the exponents, then division or multiplication is next. Right now I see this 20 divided by 4, and 20 divided by 4 is going to be 5. So now I have just 24 times 64 times 5, and you need to find that answer, and that's going to give you a value of 7,680. So you need to take some time and work that one out yourself. Okay, great. Next question, F. Okay, so or question number E, sorry. So -2 all in brackets, all to the power 0. So anything to the power 0, that just results in the answer of just 1. That's just a math definition. Anything to the power 0 is just 1. For question F, if I circle this or highlight this 2 to the power 0, that part's going to be 1 because anything to the power 0 is 1. But then you have this negative sign hanging around, so let's just insert that in the front. So your final answer here is going to be -1. Question number G. So this part that I'm highlighting in yellow, 2 to the power 0, well that's going to be 1 because anything to the power 0 is 1. And then once again you have this negative sign hanging around, so let's put the negative sign out there. Final answer, -1. Question number H. It looks like I have a few brackets and exponents, so let's do the brackets first. So that's going to be 4. 2 to the power 2 is 4. And then this 2 just hangs around there, times 2 to the power 4 divided by, well, we've seen this back in question number A, the very first question of this video review, and -2 to the power 4, that's going to be 16, right? Okay, and this 2 to the power 4 right there, that's also going to be 16, so I have 16 divided by 16, and then I have this right here, 4 to the power 2, that's going to be 16, so 16 times 16 divided by 16. And if I look at this part right here in yellow, that's going to give me an answer of 1. So my final, if I work this out, this will be 16 times 1, which is 16. So final answer there will be 16. Okay, and moving on to I, if I focus on this part right here, 2 to the power 2 in brackets, I like to do brackets first for most of these questions because BEDMAS means you do brackets first. So, whoops. So if I just continue here, this is going to be 2 squared, which is 4. That's 4 to the power 3, and then 1 over 8 times 4 to the power 3. Now this expression right here, 4 to the power 3, that's the same thing as 4 times 4 times 4, which is going to be 64. So now I have 1 over 8 times 64, which is the same thing as 64 over 1. And then if I just multiply the numerators, 1 times 64 is 64, divided by 8, divided by 8 times 1, which is going to be 8, and 64 divided by 8, that's going to be just 8. So final answer there will be 8. All right, so we want to question number 2 now. Simplify to positive exponential form, and that just means you want a positive power in your, well, positive power if you can. Okay, now the rule is when you are multiplying, and maybe I'll just blow this up a little bit more. The rule is if you are multiplying a base and a power, if the bases are the same, all you have to do is just add the powers. So this negative c has a power of 1 here. So your final answer will be negative c, and all you have to do now is add the powers, 7 plus 1. Okay, so this 7 is right there, and that 1 is right there. So this will be negative c to the power of 8. And if you expand this, this will be like negative c times negative c times negative c times negative c 8 times, right? So since we have a total of 8 negative signs, like 1, 2, 3, 4, 5, 6, 7, 8, our final answer should be positive, right? Because 8 is an even number, and if you take a negative number and multiply it like an even number of times, you end up with a positive answer. So your final answer should be positive c to the power of 8. And although there is a positive sign there, I think c to the power 8 is also an acceptable answer. Okay, so your final answer should be c to the power 8. So be careful, be comfortable with going from here to there. Okay, let's move on to the next one here. Okay, moving on to question number 6b. And for 6b, I recommend that you look at this exponent there, that power of 2. And what you want to do is you want to like distribute that onto everything into the bracket there. The first one's not too bad. Y to the power 7 times this power 2 is going to be y to the power 14. You just times the powers. 2 times 7 is going to be 14. The next part that might be a little bit tricky is distributing this power 2 onto this negative 3. That's going to be like negative 3 times negative 3, and that's going to give you an answer of 9. So that's going to be 9y to the power 14, and then this part in front you just tag along, 6y to the power negative 5. Alright, so 6y to the power negative 5 times 9y to the power 14. I recommend that you just multiply the numbers with the numbers. 6 times 9 is 54. And if you multiply the variables with the powers, like y to the power negative 5 times y to the power of 14, all you have to do now is you just add those powers. So negative 5 plus 14 is y to the power of 9. Sorry, that 9 didn't come out very well. So y to the power 9, and that comes from just negative 5 plus 14. That equals to 9, which is that guy right there. Okay, so that's your final answer, 5y to the power 9. All right, let's move on to the next one. For question number C, I see that we're multiplying. Everything is being multiplied. So if I look at this 3 to the power 8 and that 3 to the power 4, since we're multiplying with the same bases, I just add the powers. So this will be 3 to the power of 8 plus 4. And then let's multiply the numbers with the numbers. 5 times 6. 5 times 6 will be 30. Okay, so if I simplify this, it'll be 30 times 3 to the power of 12. And although this is an acceptable answer, another thing that you could do is this 30 is the same thing as 10 times 3 times 3 to the 12. And this blue 3 has an invisible 1 there, right? So if you want to combine that now, 3 to the power 1 times 3 to the power of 12, that's going to be 3 to the power of 13, right? 1 plus 12 is 13, and then you can put the 10 in front. And this is another acceptable answer if you want to go just a little bit further in simplifying your work. But this answer right here is also an acceptable answer. Okay, let's move on to the next one. Alright, so for question number D, I'm going to zoom out just a bit here. Question number D, for this kind of question, I would focus on this outside power here, this 2. And you have to ask yourself, what does that 2 do? Well, it distributes onto everything inside the bracket. Okay. Now, with the m squared and n squared, those are a little bit easier to deal with because you're just multiplying the powers, right? So 2 times 2 is 4, so this will be n to the power 4. And then you have n4, right? So all I'm doing is I'm just multiplying this 2 with the exponents there, right? 2 times 2 is 4. Okay. The trickier one is this 2 going on to this negative 36. That's the same thing as negative 36 times negative 36. And if you want to use a calculator to kind of speed up the answer there, that's going to give you a value of 1296. So then I have 1296 in front. All divided by, all right, let me just erase this now. So I have a little bit of space. Let me highlight this 3 now. This 3 will distribute onto here, so that will be n to the power of 6. And then this 3 onto that one will be m to the power of 6. And this last one is 12 to the power 3, which is 12 times 12 times 12. And once again, if I go to a calculator just to speed things up, this will be 1728. So I'll put 1728 down there. Okay. Now, after you do that, you need to simplify your work. And the first thing I'm going to do to simplify this is I have m to the power 4 and I have m to the power 6. If I have m to the power of 4 divided by m to the power 6, if I expand that, that's like having 4 m's on your numerator, and you'll have 6 m's on the denominator, and the m's can start canceling off, and you're left with 2 m's on the denominator. So if I go ahead and simplify this, I'll have 2 m's on the denominator, and by the same kind of work, I'll have 2 n's on the denominator. And then finally, what you want to do is you want to simplify this 1296 divided by 1728. Now, this will take a little bit of time here, but if I just kind of speed things up using a calculator, you can actually simplify this to 3 over 4, and that's just by dividing by 3 and then dividing by 2. If you keep on simplifying, eventually you'll get 3 over 4. So this 3 right here I'll put on the numerator, and this 4 I can just bring at the bottom here like that. So my final answer is 3 divided by 4m squared n squared. Okay, let's move on to the next one. Question number E. Alright, with question number E, I see a 49 here, and then I see a bunch of 7s and negative 7s. So this is kind of a good question to test to see whether you understand how to write numbers in terms of like changing numbers into a 7 and making sure that everything is in a power of 7, like 7 to the power of something. For example, 49 is the same thing as 7 to the power 2, right? 7 squared is 7 times 7, which is 49. I'll put that in a bracket. Then I have negative 7 to the power of 4, and then let's see here, I got just a regular 7 times 7, bracket negative 7 to the power 11. Now, if you see this multiplication sign and if you see brackets next to each other, this all just means multiplication. Okay, so if I highlight this guy right here, this negative 7 to the power 4 and this negative 7 to the power 11, I can combine those, multiply them together, and if I multiply them together, I have negative 7, and I just add the powers. So 4 plus 11 is going to be 15. Okay. And then if I look at this 7 squared and this 7 here, remember there's an invisible 1 right there, and if I combine this 2 and that 1, that's like 2 plus 1, which is 7 to the power of 3. Okay. Now, although this is an acceptable answer, you should recognize that this expression right here, negative 7 to the power of 15, if you expand that, that's going to be like negative 7 times negative 7 times negative 7, like 15 times. And that's going to give you a result of negative 7 to the power of 15. You can get rid of the bracket there. Times it by 7 to the power of 3. And now I can just add these powers. 15 plus 3 is going to be 18. So my final answer is going to be 7 to the power of 18. And then this negative sign will just tag along like that. So that's my final answer right there. Negative 7 to the power of 18. Okay, let's move on to the next one. Let's delete some of this stuff. Okay, maybe I'll just zoom in a little bit more just to blow it up. Okay, so I have the next question here. I have 3s squared all to the power 2 times t squared over s to the power 3. Okay, well, let's take a look at this exponent here, that 2, and let's just rainbow that into everything inside the bracket. So this will be like 3 squared times s to the power of 4, right? So I just multiply the powers there, times. Now all I have to do here is just multiply those powers, so that'll be t to the power of 6 divided by. Now this 3 will also go with the denominator. There's an invisible 1 there, so 3 times 1 is just 3, so that will be s to the power of 3 there. Sorry, I realize it's kind of hard for me to write. Okay, let me just zoom out here. Let me just rewrite this as bracket t to the power of 6 divided by s to the power of 3, close the bracket. And let's go ahead and just simplify the things that we can simplify. 3 squared, that's going to be 9 times. Now, this one's a bit tricky here. I have s to the power 4 divided by s to the power 3. So that's kind of like the same thing as s to the power 4 divided by s to the power 3. And you'll notice that if you expand the numerator and expand the denominator, the s's will cancel off, giving you 1s on the numerator. So we can just bring that right there as 9s times t to the power of 6. So that is your final answer right there. Okay, let's move on to the next one. Okay, for the next one, I have a 3 here and a 3 there, and I'm multiplying. So if the bases are the same, and when I say the base here is going to be 3. If the bases are the same, all you have to do is just add the numerator, or sorry, add the powers. So this would be 3, and my powers are a plus 1, and then since I'm multiplying, I just add the other power. So this is negative 2a plus 1. Okay. So my final answer here would be, well, if I have 1 apple and if I take away 2 apples, then I'll have 1 apple that I owe, and then 1 plus 1, that's going to be positive 2. So 3 to the power of negative a plus 2. And this one here I'm going to skip because that question kind of repeated itself in the previous section, so I'll move on to question number 3. So for question number 3, I need to use less than, equal to, or greater than to complete the following. Okay, so I have 2 squared. So 2 squared is 4, and 2 cubed is going to be 8, because that's 2 times 2 times 2. And 4 is less than 8, so the symbol I need here is less than. Okay, that one's not too bad. Moving on to the next one, 1/2 to the power of 100. Now, if I distribute this power onto the numerator and the denominator, that's going to be 1 to the power of 100 divided by 2 to the power of 100. And 1 to the power of anything, like 1 times 1, 1 to the power of 100 is like essentially 1 times 1 times 100 times. That's simply going to be 1. And I'll leave this as 2 to the power of 100. Moving on to the next expression here, this is the same thing as 1 to the power of 400 divided by 2 to the power of 400. And once again, 1 to the power of anything is going to be 1 divided by 2 to the power of 400. Now, hopefully here you can see that this denominator, 2 to the power of 400, is much bigger than 2 to the power of 100. Now, you have to ask yourself, if the denominator is getting bigger, then your final result has to be getting smaller. So picture this. Let's just say this is the same thing. This expression right here is the same thing as getting 1 out of 10 on a test. And this expression right here on the right, that would be the same thing as getting 1 out of 100 on a test. Now ask yourself, which one of these test scores is better, getting 1 out of 10 or getting 1 out of 100? Well, I would rather get 1 out of 100. Sorry, I would rather get 1 out of 10, because that's going to be 10% compared to getting 1 out of 100, which is 1%, right? So that would mean that this expression is bigger than the other expression. So the sign that I need over here is going to be bigger than, because 1 over 10 is bigger than getting 1 over 100. Okay, and we're going to use the same kind of thinking for the next question as well, because for C, once again, I got just different powers here. This will be 1 to the power 200 over 2 to the power 200, and this will be 1 to the power 200 over 3 to the power 200. If I simplify this, this will be 1 over 2 to the power 200, and this will be 1 over 3 to the power 200. Now, once again, this 3 to the power 200 is much bigger than 2 to the power 200, so that means the opposite fraction is bigger, so this side is much bigger. This is the same thing as the 1 out of 10 over 1 out of 100 test kind of example, where getting 1 out of 10 is bigger than getting 1 out of 100 on a test. So the symbol I need here is greater than. Okay, moving on to question number D. Now, the only problem with question number D is that there's this negative sign here, and there's this power like 321, which is an odd power, right? That's an odd power. Now, if you have an odd power with a negative number in front, then your final answer will be negative. So let's just say this is going to be a negative 1 over, well, using the same kind of power rules. Okay, so everything gets raised to the power of 321. Now, in order for me to kind of solve this problem, let's just pretend that this negative sign is not there, okay? Let's just pretend that negative sign is not there. If I went ahead and simplified this numerator would be 1, and this other numerator would also be 1. And once again, let's just assume that these negative signs aren't there. In my previous problems, I noticed that this denominator was bigger than that, right? And right away we assumed, okay, the answer has got to be like, has to be greater than. Okay, now if you insert the negative signs, once they come into play, what that really means is you got to flip this sign to the other way, going that way. Okay, and the way I would kind of describe something like that is, although 1 out of 10 is bigger than 1 over 100, which is what we've been doing in the previous problems, if I put a negative sign there, then this is no longer true. It's actually the opposite. Negative 1 over 100 is definitely going to be bigger than negative 1 over 10. And you can verify that on a number line, because on a number line, this is 0 and here is negative 1. This number is going to be maybe over here, or else this number will be somewhere over in that region, so this fraction will be bigger. So you need to have a less than sign to complete question number D. Okay, let's move on to the next set of questions in this review, polynomials review. So in these questions, we have to simplify these. Not too bad. I mean, question number 1A, I mean, here's a 4x and there's a negative 5x. So if you have 4 x-men and you lose 5 x-men, you're left with negative x. All right, and then let's just highlight the similar terms here. I have a plus 3z. There are no other z's, maybe, and there's an 8z there. So if I combine those guys, 3 plus 8 is going to be plus 11z. And finally, if I have negative 8 and negative 4, that's going to be negative 12y. Okay, so think of this negative 8y and this negative 4y is like you owe your mom $8, and if you owe her another $4, then you owe her a total of $12. This means you owe money. Okay, great. Let's move on to the next one here. For B, let's go ahead and find the like terms. So here's 4x squared. And here's a negative 7x squared. So this is kind of like you have $4 and then you owe someone $7. That means you owe them $3. Okay. If I have a plus 8x, I don't see any other 8 single terms, so that will be plus 8x. Okay. Here's a negative 7xy, and there's a 14xy. So if I combine this and this, negative 7 plus 14. So remember, it's like you owe your mom $7 and you pay back $14. You should have a surplus of $7, 7xy. Okay, and then if I have a 14x squared y, and okay, so this one I want to delete some of this stuff now, and this 14x squared y is actually a like term with 17yx squared. So these two things are like terms. Now, you have to recognize that x squared y is the same thing as yx squared, right? Those two expressions are the same because mathematically, if you think about it, 3 times 2 is the same thing as 2 times 3, right? So those are like terms. So if I add 14 plus 17, I believe that will give me a 31 x squared y. And then finally, there's this negative 8xy squared. I don't see any other like terms, so we'll just tag that on at the very end, and that should be your final answer. Okay, let's move on. Question number C, once again, you want to highlight the like terms. So here's a 3xy, any other xy's, here's a 4xy. So if I combine those, 3 plus 4 is 7xy. And then I have this negative 2yz and another negative 6yz, so that's going to be a negative 8yz. And then I have a plus 5xy and a negative 10x, sorry, there's a 5xz minus a 10xz, so 5 minus 10 is going to be negative 5xz. Okay, so we want to question number D now. Now, the like terms I see here are here and here, so we're still using the same concepts, it's just that we're just dealing with ugly numbers. So since both of these guys have a y squared, you know, I'll start off by putting a y squared down, and then I need to compute this negative 1/2 plus a quarter. So if I do negative 1/2 plus 1/4, get yourself the same common denominator, so this will be 4 on the denominator there, so I just times the top and bottom here by 2, and if I add these fractions I should get negative 1 over 4, so this will be negative 1 over 4 there. That's just putting that over there, and then I need to combine this 2/3 y, let me just delete all this, sorry, kind of messy there. Okay, so let me highlight this, plus 2/3 y and this negative 1 over 6y. Let's just do that on the side over here. So if I have 2/3 minus 1 over 6 is a separate calculation. Once again, I need to get the same common denominator, so I can times the denominators. I can change the denominators to 6, so times that by 2, times that by 2, so that'll be 4 over 6 minus 1 over 6, which, sorry, 4 over 6 minus 1 over 6, it will be, sorry, another mistake, 4 minus 1 is going to be 3 over 6, which is 1/2, so this 1/2 will be plus 1/2 y. Okay, alright, so sorry about all those small mistakes, but there is my final answer for that question. Alright, let's move on to the next one here. Question number E is once again all about finding the right terms here. I mean, here's an st squared, 1.8 st squared. Here's another st squared term, so 1.8 minus 0.7. If I combine those numbers there, that's going to be 1.1, right? 1.8 minus 0.7 is 1.1 s squared t. Right, and then I have this negative 7.2 st and this negative 4.8 st. If I combine those, that's going to give me final answer of negative 12 st. And then if I combine these three guys, 1, 2, and 3, if I add those together, 0.8 plus 4.2 is going to be 5, and then 5 plus, there's a 1 here, so 5 plus 1 will be 6, so this will be 6 st squared. Okay, let's move on to the next one here. Moving right along. Okay, so for this question right here, it's stating that evaluate the expression for x equals to 3, 2, and z equals to negative 1, and the question tells you to simplify first. So if I'm simplifying, we've got to find like terms. So here's a negative 3xy, and here's a positive 6xy, so that's going to be, so if I combine those guys, that would give me 3xy, right? Because negative 3 plus 6 is positive 3xy. And then if I combine this guy right here, the 5yz with this yz, that's going to be 5 plus 1, that's going to be plus 6yz. And then I had this negative 2xz and this negative 5xz. If I combine those two, that's like negative 2 minus 5, which will be negative 7xz. Okay, so right there I did combine all the like terms, and then anytime I see an x there, I need to replace that with this 3, right? So let me just erase all this now. So anytime I see an x, I need to replace that with a 3. Anytime I see a y, I replace that with a 2. Anytime I see a z, I replace that with a negative 1. So this will be 3 times 2 plus the 6, and the y is going to be 2, the z will be negative 1, minus 7, x is going to be 3, and the z will be minus 1. Okay, so just you can just compute this. This is 9 times 2, which is 18, This would be negative 12, 18 minus 12, and then I have, be careful here, there's a negative sign there, but 7 times 3 is 21, but since you have two negative signs, that's going to be plus 21. And if you add those all up together, you should get a final answer of 27. Okay, moving on. Write an expression for the perimeter of the figure below. Okay. One thing that I noticed right away is this part right here is R, and I noticed that this part here is Q. So this whole length right here in yellow, that's going to be R plus Q. If that's R plus Q, then the opposite side, which has the same length, this has to be R plus Q. Okay, so hopefully that makes sense. And one more thing that might be a little bit tricky is if this top length is P, then this bottom length, this piece there, that piece there, and that piece there, this whole piece right here is also going to be P. Okay, so if I add up the perimeter here, if I add this top piece, which is P, this entire bottom piece is also going to be P. So P plus P is going to be 2P. That's the top and the bottom. And then I need to add the sides, R plus Q and R plus Q. So I need to add two of those, right? I need to add two R plus Qs. Okay. And then finally, let me just delete all this. The last thing that you need to add are these little Qs. So that Q and that Q, and there's two of those. So my final answer, I just need to add plus 2Q. Okay. And if you go ahead and if you want to rainbow this, the final answer will be 2P plus 2R plus 2Q plus 2Q. And if I combine those two like terms, 2Q plus 2Q, that's going to be 4Q. So that part right there is going to be 4Q. And that should be your final answer. Okay, let's move on to another question here. Simplify. Alright, so these questions aren't too bad. Just be careful that you understand the difference between adding variables and multiplying variables. Now, anytime you have these brackets, and if you have nothing in front, so this blue part, there's nothing in front there, there's just a positive value, right? There's nothing there, so if there's something there, you can just remove the bracket. So this will be 4x plus 3. Same thing here, for this bracket there, this 2x minus 5, look at the stuff in the front. If it's a positive number, then you can just remove the brackets. So that positive stays there, and then just remove the brackets. And now it's a simple question. 4x plus 2x, that's going to be 6x plus, well, it's not plus, but if I combine this 3 and this negative 5, that's going to be negative 2. So 6x minus 2, final answer. Let's move on. For question number B, if I look at this first bracket, notice that there is nothing in front, just a positive 1 there. If that's the case, just remove the brackets, 1 minus 3t. Now over here, there's a negative sign, right? So that negative sign actually will distribute. So that's going to be positive 2, positive 5t. Okay, so the negative sign, once it multiplies right through, when we rainbow it through, the negative signs become positive. And then just combine like terms. Here's a 1 and here's a positive 2. 1 plus 2 is going to be 3. And then if I have this negative 3t, and if I combine that with the 5t, that's like you owe your mom $3 and then you pay back 5, then you have a surplus of $2. So 3 plus 2t, final answer. Let's move on. Okay, so with question number C, there's nothing in front of there, so 3x plus 2, I just remove the brackets. The next one, there's a minus sign, that changes everything, that goes right through, so that'll be negative x minus 4. And then over here, there's just a plus sign, so I just remove the brackets, so plus x minus 7. Okay, and then just combine the like terms, 3x plus x, that's going to be 4x. Oh, sorry, I made a mistake. This 3x minus x, that's 2x, plus another x, that's going to be 3x, so yeah, that's 3x. And then 2 minus 4 is negative 2, and then minus another 7 is going to be negative 9, so 3x minus 9, final answer. Moving on. Okay, so notice that I have nothing in here, and there's a positive sign there, so that means I can just remove the brackets, so 17n squared minus 17n minus 5 plus 4n squared minus 3n plus 14. The next bracket, there's a problem because there's a negative sign. We distribute that negative sign right through, so that's going to be negative n squared minus 13n minus 23. Okay, from here on, all we have to do is just collect the like terms. So here's 17n squared. Here's a negative n squared. So if I combine those, that's the same thing as 17 minus 1. So that's going to be 16. Okay, but I have another one over here. So let me think here. So 17 plus 4 is 21 minus 1, that's going to be 20, so that's going to be 20 n squared. And then I'll use my blue color next. There's a negative 17 minus 3n, so negative 17 minus 3n, that's going to be negative 14. And negative 14 minus another 13, that's going to be negative 20. Sorry, I think I may have miscalculated a few things. If I have negative 17, and if I minus 3 from it, that's going to give me negative 20. And negative 20 minus 13, that's going to be negative 33n. Okay, so I apologize for some of the wrong calculations that I may have mentioned, but I did correct the final answer there. And then finally, we have this negative 5. Plus 14, so negative 5 plus 14, that's going to be 9, and then 9 minus 23 is going to be negative 14, so negative 14 there. There's my final answer right there. Okay, let's move on to the next one, question number E. Sorry, after you do all these math problems, you start getting tired and you start saying the wrong things, but I think the final answers do work out to be somewhat correct. Okay, so for the next question here, this expression right here, the 4a squared b, that just stays the same. And then I can just distribute this negative 5 right through, so negative 5a plus 5b squared. And then since this is a plus, nothing happens there, but I need to distribute this a right through, so plus a squared plus 5a. So remember, a times a is going to be a squared, okay? That's how we get that a squared down there. Okay, and after that, the only thing that I can really combine is I have this negative 5 and this plus 5. Those will just cancel off, right? Negative 5 plus 5, they just cancel off. So your final answer is 4a squared b plus 5b squared plus a squared. And that's it. That's your final answer. Okay, let's move on. Question number F. Right away, we gotta do the rainbow trick again. A times a is a squared, plus a times b squared is just ab squared. This negative 2a, that's distributing onto everything in the next bracket, so this will be negative 2a squared, and then a negative and a negative is going to be positive 2b squared, and then this last term just tags along, plus ab squared. And then you just gotta combine the like terms. I have a positive ab squared there and a positive ab squared there. That's going to be 2ab squared. And another thing we have to look at is this a squared and this negative 2a squared. Those are like terms because both of them have an a squared. So this is like a 1 there, right? 1 minus 2 is like you have $1 and then you owe someone $2. That's going to be negative a squared. And then finally, you just have this plus 2b squared, and that's it. That's your final answer. All right, let's move on. What do we have next? Expand. All right. So for these kind of questions, whatever expression you have on the outside of that bracket, you're just rainbowing that right into your brackets. So when you're multiplying variables to variables, you just raise the powers. So there's an x here and 2 x's over there, so that's going to be negative 4x cubed, right? Y, and then a negative becomes positive. And if I distribute, sorry, let me just delete all that. If I take this negative 4xy and if I multiply that over here, that's going to be 4x. And since there's a y squared and 1y there, that's going to be y to the power of 3, right? So y times y to the power of 3, sorry, y to the power of 2, that's going to give you y to the power of 3, which is that guy right there. Okay, so this right here is my final answer. Okay, let's move on to question number B. Alright, so once again, here's my outside expression, and let's just distribute this right into the brackets. This is going to be 2x, y, well, y squared and y, that's going to be y cubed, minus, okay, so over here, be careful, if I multiply this 2 with that 2, that gives me a 4, so this will be 4x cubed, y cubed, and then plus, let me just kind of delete some of this now. If I do this 2 times 3, that's going to be 6. X times x is x squared, and y squared times that y will be y cubed. And that should be that should be my final answer for that one. Okay, let's move on to question number 6a, expand and simplify. So whenever you're multiplying two expressions in a bracket, you're dealing with the FOIL concept. So FOIL means first, O means outer, I means inside, L means last. So let me just maybe blow this up here, zoom in, zoom in. Okay, so using the FOIL technique, I do first times first. So x times x is going to be x squared, and then x times -4 is going to be -4x, and then 3 times x is going to be positive 3x, and then 3 times -4 is going to be -12. And usually when you do the FOIL questions, it's usually the middle terms that combine. So -4x plus 3x, that's the same thing as you owe your mom $4 and you pay back $3. That's going to be, you still owe her $1, right? So that's going to be -x minus 12. That's your final answer. Okay, moving on to the next one. Once again, FOIL. FOIL means first term times first term. So 5 times 4 is 20. And then x times x, that's going to be 20x squared. And then 5x times -y is going to be -5xy. And then 3y times 4x is going to be positive. It's positive because there's a positive sign there. That's going to be 12yx. And then finally, the 3y times the last one, that's going to be -3y squared. And it's negative because there's a negative sign right there. And once again, with FOIL questions, you can usually combine the middle guys. Even though you have an xy there and a yx there, I mean, those are the same thing, right? I mean, you could still write this as xy, they're the same thing. So the kind of language that I've been using in some of these videos and in class is that if you owe your mom $5 and you pay back $12, you still have, then you have a surplus of $7, and then this last term just tags along, and that's your final answer right there. Okay, we want to question number C. Question number C, the only problem with question number C is you have fractions, but you're still following the same concept. If you have 1/2 times 3, that's going to be the same thing as 1/2 times 3 over 1, which is 3 over 2. So this will be 3 over 2x. And then 1/2 times -1/4 x will be -1 over 8x squared. Okay, so with that one right there, it's kind of like you just do 2 times 4, that gives you the 8, and then 1 times 1 gives you the 1 there. And then multiply the inside terms. 3 times 3 is going to be 9, and then 3 times that is going to be, first of all, negative because there's a negative sign there. 3 times 1 is 3, and then, and then the 4 just tags along, so 3 over 4x. Okay. Now this one, unfortunately, the middle terms, they do not combine. So what you need to do is, here's an x term, a -3 over 4x, and there's a 3 over 2x at the beginning. You want to combine those. So 3 over 2x minus 3 over 4, I mean, you want to do this calculation on the side perhaps. If you change that by times it by 2, that's 6 over 4 minus 3 over 4, which is going to be, 3 over 4. Okay, so if I go ahead and simplify everything now, there's that 3 over 4 x, and then x squared plus 9. So this is an acceptable answer for that question. Okay, and once again, this 3 over 4x, that just comes from combining this blue guy and that blue guy right there. Okay. All right, let's move on to the next set of questions.